All right, so example 4 says QP equals 3 parentheses x plus 1, RP equals 5x minus 3. What is the radius of the inscribed circle of JKL, triangle JKL? So what you're going to see here is that KP cuts angle K, angle JKL, if you will, in half, right? So this angle is marked equal to this angle, congruent. And LP bisects KLJ because these two pieces are the same. So what we have is two angle bisectors meeting at point P, meaning that point P is the in-center of this particular triangle. And the relationship of the in-center is the in-center is equidistant from each side. So distance from P to Q perpendicular to side JK and the distance from P to R perpendicular to side KL should both be the same amount because they're both radii of this inscribed circle, which means that QP is congruent to RP. They're both radii of the same circle, and therefore if they're congruent, they must be then equal in length All right, so QP has to equal RP. The reason that congruent objects are equal is because the definition of congruent segments, right? If two segments are congruent, then they're equal. That's basically the definition of congruent segments. So, in this sense, QP's measure is 3 times x plus 1, so 3 parentheses x plus 1 should equal RP's measure, which is 5x minus 3. Or sorry, 5x minus 3. I'll say plus for a second. So again, we take a geometric property to allow us to come up with an algebraic relationship that allows us to set up an equation. And then we go and solve the equation. This one happens to have parentheses in it, so my first step of solving would be to distribute this 3 through the parentheses. I always want to get rid of parentheses first. 3x plus 3 equals 5x minus 3. I need to get x on one side, numbers on the other. It doesn't matter which side's which. I'm going to go ahead and move x over here and numbers over there. So the 5x, which is on the right, is moving left, becomes negative. The 3 is on the left, moving right, becomes negative. 3x minus 5x I subtract because the signs are different. It's negative because 5 is bigger. Negative 3 minus 3, the signs are the same, so I add. They're both negative, so it's negative. And if negative 2x equals negative 6, divide both sides by negative 2, leaving with x equals positive 3. The directions on the problem say, what is the radius of the inscribed circle of JKL? Well, the radius is either RP or QP. Take your pick. I'm going to go with RP. So RP is the radius. Its measurement is 5x minus 3. Instead of writing 5x, though, I'm going to write 5 times 3 because x equals 3. 3 times 5 is 15. 15 minus 3 is 12. So the radius is 12. As with all these property problems, I don't know if you watch back all these videos, I probably said every video, the properties aren't very difficult by themselves. The difficulty is the number of properties you have to know in recognizing structure. So in this particular case, you see two angle bisectors, you have an in-center, and in-center is the same distance from the sides. So know your properties, know what happens when you do specific things to triangle parts.